So this is week 1 video series of developing measurement and concepts. This is part 2, and we'll look at first grade standards. So this first one we're looking at, this activity, we're thinking about the words that are going to represent longer and shorter. So when you're looking at the standard of measurement data for first grade, this second standard really just wants to see if the students understand the longer and the shorter than. So Abby is, so now we're comparing Abby to Spot, and we would say that Abby is shorter than Spot. And then we would look at A and B, and it would be kind of close, but we would say that B is shorter than A. And then we've got the American flag and the chef hat, and we would say that the American flag hat is shorter than. And then we would look at the darker bat's wing, and we would say that it is longer. So the darker bat's wing is longer than the lighter bat's wing. So here's your darker one, there's your lighter one. So just looking at the different terminology, and this is something that if you have on the page and the student's struggling with trying to figure that out, you could use your base 10 blocks of your longs, which represent 10, and you could use those and the students could measure those as they're kind of creeping into that, understanding how to use a ruler or with inches or centimeters, a base 10 block with that standard measurement of how many unit cubes is it, and then they can compare those number values. Here we've got a little bit of a background, so it allows the students to, they could even use the background. You don't have to tell them that at first, but you could just say, well, let's do the comparison. Okay, we're going to stay with that longer than and shorter than. So paintbrush A is in comparison to paintbrush B. Well, they're not next to one another, and maybe that geometric spatial idea for some kids is kind of difficult. Well, they can use the centimeter or the blocks, base 10 block if they need to measure, and they can also use the background with the stripes in the background and think about, well, paintbrush A is approximately 1, 2, 3, almost 4 of those segments, and paintbrush B is 1, 2, 3, around 3. Well, then we would say paintbrush A is longer than paintbrush B. Some students maybe just be able to look at that, reason that, figure that out. Some kids may need to do a measurement to see that, and that's okay. When you look at the spoon in regard to the fork, so the spoon, 1, 2, maybe not quite 3, so 2.5. And then that's terminology that you can use. Well, it's about halfway through this column here. If we're able to split that in half or divide it into 2 pieces, because you're going to start to have that conversation about fractions. And you would say that the spoon is shorter than the fork. And then we could say, well, the spoon, just erase everything here, and let's say, okay, well, the spoon is shorter than paintbrush B. True or false? Well, I would say true or false, and then how can you tell? So we're looking at the spoon, paintbrush B. Spoon looks like it's about 1, 2.5, and paintbrush B looks like it's 1, 2, and so it's definitely 3. So the spoon is shorter than paintbrush B. That would be true. And you would want these types of questions if they're going to answer true or false. You have a 50-50 shot there. At least have them kind of justify how they know that in determining those answers. This next one is a really good activity that supports your standard. And it's actually going to support standard, first grade standard measurement and data, number 2. And what it wants the students to do is use those centimeter cubes or those base 10 blocks to measure how long something would be. And so when you're looking at a pencil, and then with all of these on paper, the students could actually take the base 10 block and measure that and determine. Now, understanding that answers are going to vary some with just the beginnings of trying to measure things. And since we're not really to that point of saying, okay, let's measure this using a centimeter ruler, and we see that it's 3 2/10, they're not quite ready for that yet. So you're still kind of hanging on to that. It's a non-standard measure in some way because you're thinking about blocks, but you're starting to standardize that a little bit more, where you're moving from measuring something with hands or finger length to something like a base 10 block long, which represents 10, using that to measure, and then how many of those it would take. And then you start to transition that idea into, okay, now we can start to take things with the centimeter ruler and measure, or the ruler in inches and measure that item. So, go ahead and give those centimeter rulers, those base 10 blocks out to the kids and let them measure that length of that pan and the length of that pencil and the shoe and the paintbrush, and they have to turn it, and then they see this would be more vertical, and the lunchbox would be vertical, and the ant would be alongside like that. And then you see you've got others as well. I thought I had some more on there, but you got the cupcake, and you would measure the cupcake as in the same manner. So great activity, beginning that measurement with unit cubes, which we'll see moving into using the centimeter ruler. With this next one, you see that we're looking at 1G1, so we're starting that geometry measurement. We're starting to look at characteristics and attributes again. So down below here, we've got where the students would color the different, they're looking at different shapes. And so we would say, let's color the shapes. Let's go to red, and let's color all 4-sided shapes. So now that you start to, you don't have to necessarily correct them, but you can definitely get them thinking, all right, I want you to think about 4-sided. The first thing that might pop into their mind is they're thinking square. But remember that they can think rectangle, and they can also see that what we're going to have here is a 4-sided figure. This is the beginnings of what we call a trapezoid. And then we've got 4-sided figure that's similar almost to a rhombus. Here we've got a square and another square and a rectangle and a smaller rectangle. So it looks like we have 7 shapes that are 4-sided. And then we look at and go in green, and we're looking for 3-sided shapes that would be in green. So here's 1, 2, and then we see that we have 3-sided shapes, which would be, we could say triangles. We could start to use some different terminology like 4-sided shapes or quadrilaterals. It's okay to throw those words at them. They're going to hear them down the road as well. So as long as you know where that's going in that terminology, then use some of that terminology at that time. anytime a student that may ask a really curious question about something down the road, it's really good for you to have that content knowledge to be able to say, that's a great question. That's not in particular to what we're studying right now, but that's a great question. And that item is fill in the blank. That's a great question. That characteristic is going to fit this item that you'll learn in second grade or that you'll learn in third grade. So kind of praise them for really thinking outside of what you're talking about currently. A five-sided shape. Well, what would we call a five-sided shape? And we're going to look at that in yellow. And looks like we don't have any, so we would say that that's 0. We don't have any five-sided shapes. Unless we'll color black if we have a six-sided shape, and we do. We've got this shape right here. So six-sided is also known as a hexagon, and we have one of those. And then blue is that we're going to say in blue they have 0 corners, no corners. So that would be our circles, 1, 2, 3, 4, 5, 6, and we've got 7 circles. And so then down below, we've just got more in regard to attributes and characteristics of shape. So a triangle has 3 straight sides and 3 corners, and we colored 3 triangles. A hexagon is going to have 6 straight sides and 6 corners, and that's what we saw here. And we colored one of those. And a circle has 0 straight sides and 0 corners, but we colored 7 of those. And then a rhombus, it's going to have 4 straight sides that are equal in length, and it's going to have 4 corners. And we colored 2 of those, which should be a little bit more to scale, but that is kind of the idea of your rhombus, where all the sides are the same length. It just angles are a bit different. And then with the rectangles, we had 4 straight sides, 4 corners, and we colored 4 rectangles. So great idea and activity with coloring. So you start to get pictures of different shapes, different characteristics, and a great discussion opportunity in class. Here we can have students write the name of the object in the correct column. So we're looking in a different standard with geometry. So we're naming that object. So we're thinking about cubes. We can see that the block is going to be part of the cube. And we also see that the dice would be part of the cube. With spheres, we would see that we've got the tennis ball, so here, and we've got the globe. Those would be spheres. With cones, we see that the party hat and then rectangular prisms. So with the rectangular prisms, some of them are called cubes because we know the side lengths are the same, but a rectangular prism is kind of that big idea and that umbrella type of representation attribute. So a rectangular prism, well, the block falls in that category of a rectangular prism, and the tissue box and the dice. They would all be considered rectangular prisms. And then we've got the cylinder and the can paint can would represent a cylinder. So really good opportunities for them to place, and write the words and associated with objects that they can see day to day. And now that they've got a picture of those, they can now connect those to an attribute of different shapes, which we see in the columns in the table. Circle the attribute that describes all spheres. So when we're dealing with all spheres, we're going to say that they are round, not necessarily bounce. And some of them could roll, but not all of them can roll. And we certainly have no straight sides, but they would definitely all be around. And then circle the attribute that describes all cubes. Well, we would say that they have square faces and they have 6 faces. Cubes are not all red and they're not all hard in that case. So you're thinking about the dice. It doesn't have to be. They could be squishy. They could be the compression type. They could be made out of cardboard or paper. So definitely these 2 items to describe those. The next activity is introducing pattern blocks to the students and having them build different shapes with composition. So you start to see, well, let's use the pattern blocks to trace or draw the information below. If I want 3 triangles and I see that I can get 3 triangles, now I want to think about, now how do I make the red shape? So if the red shape is a trapezoid and I've got 3 triangles, you think about how you can piece those together. And it may be helpful if they see that they need to, how they can place that on top of and may have to rotate a little bit. And then they can piece those together and see that the 3 triangles do make the same shape as the trapezoid. And then we could use the same shape because we want to make a hexagon, which is what we see as the white shape below. So we could use a trapezoid and then another trapezoid, which we would have to kind of rotate that. And then we piece those together and we see that we've got, something similar to our hexagon. Well, it's exactly our hexagon, except it's the composition of it is different shapes. And then this last one, we could take that hexagon and it says use the 1 hexagon and 3 triangles to make a larger triangle. So you have the kids play around with the pattern blocks and try to figure out how to make that larger triangle. And you find out that you're going to place those kind of on the sides. Kind of make that larger triangle. So pattern blocks are really good, something to manipulate, and having the kids see that different shapes will make up, larger shapes could be comprised of smaller shapes. And so then that starts to get into the progression of thinking, well, now I can start to talk about fraction ideas with the pattern blocks. And then, of course, just an extension, you could have the students kind of make an animal. And so they're making an animal and they're using the pattern blocks to create that. So they could pool some of their pattern blocks and make something at their table, or they could individually make their own. And It's just with these types of problems, they're very open-ended. So that leaves you, sky's the limit on what you want to create, and you're getting to use the geometric shapes to do that. Moving into another geometry piece of 1G3. So our third standard in geometry of first grade is now starting to look at different shapes and where you're counting parts of a whole. So now we're thinking, well, what is the whole? And then we're looking at the different parts. So when you look at A, we're dealing with the rectangle, but we also see that we've got separated and we've got two parts. And we've got to recognize that the sizes need to be the same as well. So when you're thinking about separating these into parts, the parts have to be the same. And that's what we talk about later down the road when we want to add fractions and subtract fractions, that we want the parts to be the same. That's why we look at a least common multiple to be able to create that same part, whether you're looking at halves or fourths or fifths or eighths. But here you see that it has 4 pieces. And so the number of equal parts in that shape would be 4. We see the triangle divided into 2 parts. And we see this pentagon, which is 5-sided, and it's also separated into 2 pieces. And then here's our hexagon that's separated into 2 pieces. And then we have a rectangle or a rhombus or a quadrilateral, how we want to label that, and it's also divided into 4 pieces. Next, you've got an idea where you're given the shape, and now you want to see, can the students subdivide that shape into certain parts? And so if you wanted to have the students draw a line to make this triangle into 2 equal parts, well, there's different ways to do that. Since we don't really know the side lengths on this, the logical piece would be to just drop that line straight down. It's also called an altitude. And that is not, of course, not terminology that they're going to be talking about, but it's certainly something that you could always use. There's nothing wrong with using terminology that they're going to hear in the future, but it did ask for you to make a triangle into 2 parts, and you're just drawing a vertical line or drawing an altitude or drawing a segment that's going to subdivide this into equal parts. Draw one line to make this square into equal parts. Well, you could draw a diagonal, and that would divide it into 2 parts. You could draw it right down the middle. And you could draw another diagonal, or you could draw a horizontal piece right down the middle. So you can see that you have multiple ways if you were going to draw that in 2 parts. So again, you can go from diagonal here, you got the other diagonal. That's 2 different ways. And then you've got your horizontal way to subdivide it into 2 parts. And then you've got your vertical piece to separate it into 2. Then the part D says, I want you to draw 2 lines that make the square into 4 equal squares. Well, you could look at it horizontally and vertically. So there would be approximately your 4. And then if you got your square, you could go diagonal to diagonal, which would create 4 triangles, all of equal length. Then you have pieces where you start to look at really stressing the halves. So when you're talking about halves, you're talking about, all right, we're looking at 1/2, and I'm looking at the whole, and I'm dividing it into two pieces. That's what the denominator means. You are denominating or dividing that whole into two pieces. So the denominator tells you how many pieces to subdivide, and you want halves. Well, also, I mean, we see two pieces here for part A. The problem is they're not the same size, so we want them to have the same parts. So on this one, we would say no, it's not divided into halves. And the second one would be no, because it's not equal halves. With the circle, what we have when we subdivide a circle right down the middle, all the way across, we call that a diameter. And that is, yes, that's in two equal pieces. D is also a yes, it's going from corner to corner, so it's creating two triangles in two parts that are equal. This is not going across the middle. And so since that's not a diameter, that does not subdivide the circle into two parts, so that's a no. And then our tilted square is separated into two parts. So now you're starting to really focus in on what that word half or halves, and then the fraction piece of that. And then we can look at, well, what are we talking about when we say quarters? So now you're starting to think about, it's the same standard, but now we're looking at halves and looking at quarters, and we're thinking fours. We're thinking, okay, I want to subdivide this into equal parts of 4. So I see there's 4. So that would be yes, that was subdivided into 4 pieces. I notice that these triangles are equal, and so equal in size and shape. And then this one, the rectangle from the diagonal, and then it stops. So we're looking 2, 3. That's not even 4 pieces, so that's a no. And this circle down here on F has 4 pieces, but those are not going to be the same. And neither is E. We can see the 4 pieces there, but they've got to be equal amounts. And then D is a yes. So then we start to talk about, okay, well, we're going to share with someone, do we see any patterns? You know, what are patterns that can give away, yeah, we know this is going to be subdivided into quarters. What are we thinking? You had to share that with someone. What gives it away? Those types of things that we're talking about when we say patterns. So we've looked at moving from halves to fourths, and so that we just carry that over into the measurement and data standard. We start looking at time. So we're looking at our clocks, the circular clock, and we want to talk about, and this is a great, and I know we're in the digital age, and we see so much. You look at your phones. I know there's a lot of people are debating, you know, what's the point of looking at analog clocks? And well, because fractions can be discussed certainly with the use of time. So when you're thinking about clocks, you can look at halves and think about, oh, well, it's the half hour. So even with the digital at 11:30, you can even you still understand that, well, this is a half. So you can still tell if things are to the half hour even in a digital mode. But it's a great tool to use as the clock to represent the fractional pieces. So which clock, A or B, shows half past 11? And then we would say, well, that would be A. So it would be this one. And then we want to see clock A or B that shows half past 2. Well, if we choose one, then why is B not? Well, it is half past, but it's half past noon. So this is one of those examples where students can give, you know, wrong answers, but you find something that's right about it. And so when you say half past 2, when they say, well, it's B, and it's like, well, there is a half past, it's just half past noon. So we just want to get the correct hour right. And so A would be half past 2. Well, which clock shows 6 o'clock? Well, this one shows 6 and this one shows 12 o'clock. And then below, we would say which clock shows 9:30. And then we would say that B would do that. And so why is that the case? Well, they're both showing 30 minutes past or half past, so, except part A, clock A is just shows 8:30. So the more you can really question and the more that they can see, oh, well, half past is the same as when we're talking about 30 minutes past or 30 minutes till or half past. All of those terminology pieces mean the same. And then here, you're given the clock, but you want the students to be able to draw that in. So if you want to draw 3:30, so then we start to talk about the minute hand and the hour hand. And so we can even refer back to the previous one where we see, well, we do have a longer hand here. So there's your minute hand, there's your hour hand, there's your hour hand, there's your minute hand. So your minute hand is going to be longer. So then have the students attempt that. So we're talking about, here's 3:30, or we're dealing with 8:30 or 11 o'clock. So you're just trying to make one definitely distinct. One is longer than the other, or one is shorter than the other, however you're looking at that one. This one is the 6 o'clock with the minute, and then you're going to see that overlap there. Here we want 4:30, so we want the shorthand toward the hour and the longer showing the minute. So now we can start to talk about, well, this first number would represent your hours, second number is representing your minutes. And then if we want 12:30, we see the same idea there. Okay, so you've seen a lot of different standards. So this is a good time for you to reflect. It's a great, every educator will reflect. It is part of growing as an educator. It's a part of getting better. And you're basically a work in progress. I've been teaching 18 years and I'm still a work in progress. So you're always trying to find ways to get better. And reflection is always a great way to do that. So you think about, well, what did you learn from the first grade standards when you're thinking about measurement? So that's something that you can go back and look at the handouts that I have posted in the module online. You can go back and rewind the video and look at some things that we discussed as well. Concerns or questions that you have about the standard measurements in first grade. What are some things that concern you? You're thinking about, wow, I've never taught this before. What am I going to need? These types of materials. That's why you collaborate with your peers in your grade level teams when you get into your schools. Do you foresee any struggle with first grade standards? And there's certainly nothing wrong with productive struggle. It might be something that you struggled with that you're thinking back on. Well, just because you might have struggled with it doesn't mean the kid's going to struggle with it. But if you're feeling like the students might struggle with this, you might reach out to a veteran teacher on staff or in your team and say, okay, how did you teach this? What do you recommend? What do you suggest? Or if you have a learning coach or an academic coach in your building that can sit down with you and say, yeah, we usually try this. This has been our best approach for this, and let them kind of help you through as you're beginning your career. And then look, what progressions do you notice from kindergarten to first grade? Progressions are really neat in these types of courses because you can start to see how it builds. And you're not in that tunnel vision of your own classroom and your own grade level. I think, as I close, I think there's a lot of merit and power to understanding the grade levels. And more than likely, and I did too, you're going to land at a grade level that you start teaching, and it might be first grade, that might be fifth grade or eighth grade, and you land at that grade level and you just want to be the best you can be, and you're trying to absorb all the standards and all of the information that's there. But there is something really special about understanding the progression, where the kids are coming from, where are they going, what, when you get a grasp on that, which is probably not going to happen for uh, first first while, first few years of your education career, because it depends on your principalship allows you to um, move from class to class, or if you want to go down, or you want to move up with the class, or you may just want to stay put in that grade level. It's always good to really have that conversation with people in a grade level before you and after, to see, okay, when they get to you, what are some of the deficiencies that you see? So it really kind of gives you an idea of where you need to hone your skills on certain standards. So I love the progressions, and I'm very fortunate in my job currently to be able to teach sixth grade all the way up to geometry with students, and to see that progression and know where those gaps are and how to fill those. So I know that was a lot. That was part 2. We're looking at first grade standards with your developing measurement concepts.